In the 16th question, we have integral from 0 to pi log of 1 plus cos x. How will we handle this? So, once I see this, think of applying the property 3, that is king property, cos pi minus x. Okay, this will be 0 to pi log of 1 plus cos pi minus x, which is 1 minus cos x actually. And we have 1 plus cos x already there. Okay, and then what I can do is maybe add them together. Log of 1 plus cos x, log of 1 minus cos x will be log of 1 minus cos square x, which is log of sin square x. The two can come in the front. Log of sin x is what I get, and we know one important result from there. From a past knowledge, we know that integral 0 to pi by 2 log of, had there been a sin x, this is equal to minus pi by 2 log 2. Now, this is one thing which has been solved in the NCERT, and this is something which I want you to remember as well. I've told you this a few questions back as well, but there we did not use this. If instead of sin x we have a cos x also, then this works. Same result hold, because this pi by 2 can be replaced with the help of that king property. The sin pi by 2 minus x will be cos x. Even if instead of sin x we have sin 2x, that also works, right? And that can be proved with the help of a simple idea. What is that? Log sin 2x can be written as log 2 plus log sin x plus log cos x, right? Log sin x is known, log cos x is known, and log 2, the integral from 0 to pi by 2 is known. Write them together, you will get the integral for log sin 2x from 0 to pi by 2 as this value only, as the same value only. Yes. So that's interesting. Yes. What about this one? We started with the idea integral 0 to pi log of 1 plus cos x dx. Then we apply P3, or that special case P4. This also tells me that I will be equal to 0 to pi, that same 0 to pi log of 1 plus cos pi minus x. Cos pi minus x will be minus of cos x. Or let me write cos pi minus x only over there, so that you're not getting confused with this. Cos of pi minus x dx. Okay, and this here is nothing but I is equal to 0 to pi log of 1 cos pi minus x is minus cos x dx. Now this is 1, and let's call this 2, and what I'll do is I'll simply add them together. So 1 plus 2 implies 2i, I and I in the LHS will be equal to integral 0 to pi log of, you have 1 plus cos x, you have 1 minus cos x, log of x plus log of y will be log of x into y. 1 plus cos x into 1 minus cos x will be 1 minus cos square x dx. Okay, this tells me, okay, 2i is equal to integral from 0 to pi log of sin square x. Do you observe? Log of sin square x dx. Yes, that 2 power 2 can come down. Yes. Okay, and what you'll get is modulus sin x over here 2 times this. So that will give me 2i is equal to 2 times integral 0 to pi log of mod sin x, which will be actually sin x only, because 0 to pi in this interval sin x is positive. So I'll directly write this. Yes, this 2 gets cancelled with this 2, and I will get I equal to this. But if you observe, now if I apply that a plus b minus x property P3, what I get is sin pi minus x is same as sin x. Okay, so we're getting the same function. So let's take it as 2a and apply P5 on this. P5, or the special case P6 on this. 0 to 2a log 0 to 2a fx dx will be equal to twice of 0 to a fx dx if f of 2a minus x is equal to f of x, which is already happening, right? So applying P6, this will be twice 0 to pi by 2 log of sin x dx. This is what you'll get. And now, mind you, I'll need this particular value from here applied over here. I'll need this value, without which it will be difficult. So this particular value has been already derived, and using those ideas of derivation already there in the NCERT. One of the examples is covered on this. So this will be 2 times this, which becomes minus pi log 2. This is I, which is equal to minus pi log 2, and that is my required answer for this question, as you can see over here. Is that all? Yes, that's all in this question 16th.